You already have that. I gave you 2 packets. Right before Christmas, when I gave you the big one, I gave you a little one. The little one is the review one.
It's gonna be short.
All right, here we go. All right, you people, I know what's going on here. You're like wild people. Stop. Time to get focused. We have a lot to do if we're going to get ready for this test. It's not ideal to have a 2-week break in the middle of a chapter. We need to get things pulled back together. So here I am. I'm on the practice test. And I'm going to just start at the beginning, and we're going to crank through. Whatever I don't get done, we'll pick up the next time we're together. Okay? So here we go. Cosine 5 pi over 4. Probably the first thing I'm going to want to do is change this guy into degrees. So pi is 180 divided by 4 is 45 times 5 is 225. So then what do? Draw a 225 degree angle and make a butterfly bow tie triangle. If this is 225, then this angle is 45. And the minute I do that, I can label the sides 1, 1, root 2. And then I stand back and say, look, I'm not in quadrant 1. Therefore, something is negative. What's negative? These are negative. I want the cosine. Adjacent over hypotenuse, negative 1 over root 2, negative root 2 over 2. Very good. B. We had a quiz, I think, over B. B. Yeah, some of you had it on today's quiz even. I think only one group did. What is the sine of the angle whose tangent is 4/3? So we're going to draw a picture according to the quadrants, and it would be 1, right? Choices are 1 and 4, but the number is positive. There aren't any extras over there. I know there aren't. Take a picture. Everybody got one. If you have a big packet, you have a little packet, and them all out at the same time in December. Let's quit messing around. Just get a picture of somebody. You don't need the actual sheet. Not important. Get a picture of it. So the tangent is 4/3. By the Pythagorean theorem, the other side is 5. Now answer the question. What's the sine? 4/5. Opposite over hypotenuse, 4/5. Now, what's going on in the next one? What is this one asking me for?
The sine of
The angle whose sine is negative 1/2. So the answer to this question is not going to be 4/5. The answer to this question is going to be like 45 degrees or something like that. It's an angle. I'm looking for an angle. Now, where will I look for this angle? Quadrant 4. There are rules associated with the inverse sine. That's a negative number. I've got to be in quadrant 4. The sine is 1/2. Negative. Clara?
Oh, it was just turned on, like it wasn't.
Clara? Why is it in your lap?
I just always I put it in my backpack.
Yeah, that would be a better idea. What's the adjacent side?
Oh. That's gonna be root 3.
That's gonna be root 3.
What?
How big is that angle?
Negative 30.
Right here. Negative 30 degrees. The answer to the question is negative 30 degrees. Yes.
Oh!
Are you okay? Is it an emergency?
Yeah. Well, no.
Okay, if it's not an emergency, no. If it's an emergency, yes. I don't want a mess in here. Okay. What does this one say? Find the angle whose cosine is 0. Wait a minute, there's something special about the zeros. Do you remember what's special about them?
Is it coterm?
It's quadrantal. So the rules still apply. We're only looking up here. That's what this tells me. These points, one of them is going to have a cosine value of 0. Now, think of that as 0 over 1. Where is it that x over r is 1?
90.
That would be 90 degrees. E. We're going to find the cosecant of 3 pi over 2. So that's the cosecant of 270. Uh-oh, that's another special situation. So 270 is down here. That's the point 0, -1. Your radius is 1. So you have x and you have y from the circle, and you know your radius is 1. What's cosecant? Reciprocal of sine.
So it's R over
Sine is y over r, so cosecant would be r over y, which down here would be 1 over -1 or -1.
This board.
Yes.
How do you, so like I saw, I've already gotten like 5 questions on what's wrong. How do you like know when you put it in, you need to find the degree or the numbers.
Depends what the question says. This says find the cosecant. This would say find the angle whose cosecant is.
Okay.
So the notation, it's all about the notation. That just is a regular cosecant. This is the angle whose sine. Whenever you have that notation, you're looking for an angle. Unless I put something out in front of this, then I'm finding the cosine of the angle. So this would be a cosine problem, a fraction, like 2/3 or something. All right, next. We gotta find the period of this guy. All right, so what's our strategy to find the period of this? We learned in our homework that if we really don't know, guess 2 pi, right? Because 2 pi comes out a lot. But let's see what this one is. How do you do it?
Oh, you do 2 pi divided by 3, right?
So this period would be 2 pi divided by 3. I'm going to say this one more time. The period of a sine or cosine is always 2 pi divided by the coefficient on x. The period of a sine or cosine is always 2 pi divided by the coefficient on x. So this one is pi. Now, what does that mean? That means as you go down, as you graph this thing, the steps you're taking are this big. So 2 pi over 3, 4 pi over 3, 6 pi over 3, 8 pi over 3, and so on. This one is pi, 2 pi, 3 pi, and so on. Well, once again, our first place where they overlap is 2 pi. So that's the answer to the question.
Wait, it just asked if it's sinusoidal.
It's not.
No, first it says find the period,
Oh, okay.
and then it says, is it sinusoidal, why or why not? So we found our period, 2 pi. Is it sinusoidal? No, because why?
It's different periods.
The periods of each piece do not match. Okay, change 2 radians into degrees. How do we change radians into degrees and vice versa? 2 radians.
Pi over 180.
Pi over 180 equals x over 2 or 2 over x?
You have 2 radians.
You have 2 radians, so it's got to be 2 over x. Because when you set this fraction up, what's on top? Pi radians. Radians are up here. So this has to be radians. Michaela, you writing any of this down? Okay. Don't tell me stories. I got enough of that. Answer, 360 over pi. You all right, Michael?
Yeah.
Okay. Find a negative coterminal angle for negative pi over 7.
-2 pi over 7.
No.
I got that one.
All right. How do we find just forget the problem. How do we find coterminal angles?
You do one evolution.
You add or subtract a revolution, right? Now, if we added a revolution, this would become positive. We are directed to find a negative, so we're going to subtract a revolution. Now, if I were in degrees, I would subtract 360. But since I'm in radians, what will I subtract? What's a revolution? 2 pi. So I have negative pi over 7 minus 14 pi over 7. When you are subtracting, you need a common denominator. So minus 1 minus 14 would be negative 15 pi over 7. Mallory?
So, does 360 over pi reduce?
No, it does not. This is a degree measure, not a radian measure.
Okay.
So it's about 120 roughly because pi is 3.14. Now pi radians is 180 degrees. So if you have pi in a radian problem, you can change it. So like on this one, this would be negative 180 over 7, whatever that is. Okay? So we add or subtract a revolution and then do the right arithmetic. In which quadrant is the sine positive and the cosine negative? So we need sine positive and cosine negative. Now, this is not hard. Sine is associated with which letter, X or Y? Sine is Y. Sine is Y. So if you want sine to be positive, you want Y to be positive. Where does that happen here? Where is Y positive in the coordinate plane? Here and here, right? Isn't that where Y is positive? Now, cosine, on the other hand, is associated with which letter? X. So you want X to be less than 0, X to be negative. Where is X negative? Here and here. The only quadrant that has both is quadrant 2. Given that the secant is 5/2, find the rest of them. That's what this means. Now, they gave you one other piece of information. What does this mean? What does this tell me? Is theta, the angle, I'm going to draw a picture, and the picture I draw is going to be between what and what?
270.
270 and 360. So I am going to draw an angle actually in quadrant 4. And I know the secant is 5/2, which means the cosine is 2/5. Jack, you following along? What does that make the third side?
5 minus 4.
25 minus 4, square root it, root 21. In caution, it would be negative. Everybody keeping up?
So now we just got to
So now we just got to
write together.
fill in the rest of them. Right, so what's the sign of this picture right here? The sign? Negative root 21 over 5?
Yeah.
Which means the cosecant, I'm going to run out of room. The cosecant would be,
Negative 5 root 21 over 21.
yes, negative 5 root 21 over 21. Very good. That would be the secant, or the cosecant, I mean. That's the cosecant. What's my tangent?
Negative 21.
Negative root 21 over 2.
And just flip.
So flip it, and it's going to be negative 2 over root 21, or negative 2 root 21 over 21.
This flip.
Yeah.
That is right.
Hurry up. All right, you ready? Number 7. Okay, so, all right, so I've got this. So let's see. Brenton, maybe you got this one right?
No.
No?
I don't think I had one like that.
Oh, you didn't?
Yeah, you could do that one.
All right, so in the beginning here it says, if R is 8 and theta is 100, find S. Well, what does S, what's S? S is the arc length. To find the arc length, we will do radius times radians. So our radius is 8. Uh-oh, what's our issue? Gotta change it from degrees into radians. So we already did that once today. Pi over 180 equals something over 100. So x equals 100 pi over 180, which I got 5 pi over 9. Is that right? Now, be careful, that's not the answer. That goes here, 5 pi over 9. So now I multiply those two together, 40 pi divided by 9. And if that started out as an 8-inch radius, this would be a 40 pi over 9-inch arc.
Is that an S or a 5?
S on the paper, it's the letter we use for arc length. Now, I have, if you think of this as a pie, there's really two pieces there. There's this little piece and then there's this rest of this big giant piece. It says find the area of the smaller one. So find the area of this guy right here.
So you do like 100 over 360.
100 over 360 times what? 64 pi. And where did the 64 pi come from?
That's where R squared.
It's the area of the whole thing. So you are taking 100 3/60ths of the whole. So times the whole area. And then we'll reduce that fraction. So those are going to cancel. This is going to be, what, 5 over 18 times 64 pi. I get 2 out of there and a 2 out of there. I think that's all I can do. So what is that, 160 pi over 9? And again, if that had been inches, then this would be square inches. Find the area of the larger sector. So that's the unshaded part. A couple different ways you could do that. What might be one way? How would you maybe do that? Cassie, are you raising your hand?
No.
Jack?
260 over 360.
260 over 360. why is Jack saying 260 over
Oh, 'cause you already
360
used that one.
times 64 pi? All the way around is 360, right? If that piece of it's 100, isn't the rest of it 260? So he says one way to do it would be to set up this fraction. So that's 13 over 18 times 64. Oh, I'm probably gonna need a calculator here, because that's 9 and 32.
You got yourself.
13 times 32. 416 pi over 9, maybe?
Couldn't you subtract?
Oh, wait. This is one way to do the problem, right? This is one way to do the problem. Everybody in agreement? So if that makes sense to you, that's how you're gonna do it. All right, Brooke, was that you talking? All right, let's hear Brooke's idea.
Subtract 160 pi over 9 from 64 pi.
Exactly. She says, this is fine, you can do this. I hope I multiplied right, I really don't know. She says, what if you took 64 pi minus 160 pi over 9?
Then you gotta find the common denominator.
Well, yeah, but would that work?
Yeah.
It's a different set of arithmetic, so you kind of pick which one you want to do, but she's exactly right. The area of the big one is going to be the whole thing minus the area of the little one. So you have that option too, right? All right, number 8. We're going to sketch one period and list all this stuff.
Would number 7 be a calculated part?
Probably not.
Even if it's that complex?
Don't say that kind of stuff. That's not complex. It's tedious. We don't like doing it, but we can do it. All right, we're going to sketch this. This is one of the areas where I think you're the weakest. So let's go ahead and get this thing
So the
figured out.
amplitude is 2.
So we're going to sketch it. But before we do that, we're going to list the amplitude, the period, the phase shift, the vertical shift, and the frequency. So what can you tell me about this? What's going on here? What can you tell me about any of those blanks then? Can you fill in any of those blanks? Brenton?
So amplitude is 2.
Amplitude is 2, which means when I get around to sketching it, I'm going to go up 2 and down 2. All right, what else?
The period is 4 pi.
And he knows that because period is 2 pi divided by the coefficient on x,
So that means
and the coefficient on x is 1/2.
that means the frequency is 1 over 4 pi.
Yep, because frequency is always the reciprocal of the period.
And the vertical
Shift.
shift is like what, 1/2 times pi, negative pi over 8.
There's no vertical shift.
There's no vertical shift.
Oh,
The vertical shift is 0. Why is there no vertical shift?
because it's not outside.
Because there is no like +1 on the end. That would be a vertical shift, right? Don't have that. Brenton,
Yes.
you done? Or you want to keep going?
Oh, I'll keep going.
All right, what's our phase shift?
So our phase shift is is it, you gotta do, oh okay, just negative pi over positive.
Right.
Goes right. Goes
Oh,
to the
pi over
right.
8.
Goes to the right, pi over 8. There's your phase shift. Positive pi over 8. Okay? Anybody have an issue with any of those numbers? He's right. Jay? Oh yeah, if you have a pass, go ahead and go. Next time, let's kind of plan better so we're not missing math.
Okay.
This one of those other subjects that's not really important. In case some administrators watching. All right. Here we go. Now we're ready to sketch it. This curve, this is a positive cosine curve. Normally, a positive cosine curve looks like this. You need to know what a cosine curve looks like. It's one of your BFFs. There's no excuse for not knowing that. That's what it looks like normally. It normally starts right here. Yours has been shifted, so now it is starting here. It is exactly the same picture, but it is starting up here. And ending then up here. Now, your first task is to find the ending mark.
So 4 pi plus 5 over
Exactly. I don't know why we sometimes struggle with that. The concept is so easy. You are starting at 1/8. You are traveling 4. So where will you end? At 4 and 1/8, right? Now we're going to be doing some arithmetic with that, so I'm going to write 33 pi over 8. But that's the same as 4 and 1/8. You're starting at 1/8, going 4. 4 and 1/8.
Yeah, because that's what she's got confidence.
Yep. This, and the reason I did that is because I'm going to have to find the midpoint of 1/8 and 33/8.
So then 34 divided by 2.
Exactly, which would be 17. Very good. I'm finding the midpoints now of 1/8 and 17/8. 9/8. You're adding them and taking half. 17 and 33. Half of it would be 25. Yeah. And we're done. That one's done.
Easy.
Yep. Number 9 is the same thing. You're graphing again, except it is a tangent problem. Now, this is not one of your BFFs. However, it was on your required memorization, and we have done other tangent problems. So let's fill in all the stuff first. We have a negative tangent.
They don't have an amplitude.
You don't have amplitude. Brenton remembers Mrs. Ford making a big, huge deal about the fact that only sine and cosine have amplitude. Everything else just shoots up into space. In case you've forgotten, your tangent curve looks like this.
Period. 5 over 2 pi.
No, you divide by 5.
The period's 5.
The period is pi over 5. Now, some of you are saying 2 pi over 5. The normal period for a sine and cosine is 2 pi. If it's a sine or cosine problem, you're doing 2 pi divided by the coefficient. But what is the period here, guys? From negative a half to positive a half. What is the period of the tangent?
That's 1 pi.
Just 1 pi. So the 5 still divides, but now it divides pi. So your period is pi over 5, which means your frequency is
5 over 5.
5 over pi. Does this problem have any shifts, any vertical or horizontal shifts? No, because there are no plus signs or minus signs in the problem.
But it does flip.
It will be upside down. So instead of going up like this, it's going to be coming down like this. So in fact, I'll just graph it right here. There's an asymptote, there's an asymptote, and here it comes down. It's upside down because of the negative. The only thing you need to figure out is, where are the asymptotes? Well, that's easy. The period is pi over 5. that means from this asymptote to this asymptote is pi over 5. So what are these labels going to be? Pi over 10. If the whole thing is pi over 5, don't we have to go half this way and half this way? So half of a fifth is a tenth. So we're going to go a tenth both directions. And that's it, right here. This is the one. For your reference, this is a normal tangent. This is the answer to the question. Okie dokie smokies. All right. Now we're getting out our calculators. Oh no, number 10. We gotta do number 10. And then we'll get our calculators. But first, let's do number 10. Number 10 is one of those like we did the other day. That's the backwards of all this. So you've got an equation. It's very, very similar to the one we did the other day, I think. What am I doing? I'm going up 4 and down 4. Okay, so I'm going to write an equation of this. And what did we talk about yesterday? You're not writing just one equation, you are going to write 2. Because there's no way to tell by looking at this. It goes on forever and ever. There's no way to tell whether this is a sine equation or if it is a cosine equation. So you are going to have to come up with an equation for each. So when you just first look at it, what do you think of when you just look at it? You think of a cosine. So Brenton is thinking about, I'll do it in purple. Brenton is thinking about this right here. Brenton is allowed to think about any part of that curve he wants. And he has chosen to think about that part. Now, the part he thinks about has to be a complete cycle. So he can't think about just this part, for example. He has to go from top to top. Okay? Or bottom to bottom. But he needs a whole cycle. So he's doing a cosine. All right, let's start filling in blanks. Can you fill in any of those blanks for this cosine curve? The 4 out here in front, and it would be a positive 4, right? Because that cosine is right side up. Valerie? Did you tell me you lost your book? Are you the one that told me you lost your book?
Yeah.
Does it have your name in it?
No, it has my purple sheet on it. I think that has my name on it.
No, your name's not on the purple sheet either. This is very dangerous. Do
It
not
has a
leave.
weird name that I don't know. It has 2 CDs in the back.
Yes. Julie Boutet.
She's trying to prove it. Thank you.
You know where it was found?
I don't want to know.
The bathroom.
No. On top of the pop machine outside the aux. Perfect place for a pre-cal book. Good thing I go to the weight room every day. I looked up there and said, what is that? Okay, here we are. Amplitude's 4. What else can I fill in? Cosine curve. Well, I'm gonna have, I can find the period. That's the hardest one to fill in. That's this blank right here. And I know that for cosine, period is 2 pi divided by that number.
So do you do 2 pi over n equals 4 pi over 6?
Exactly, because the period of this curve, hill to hill, is 4 pi over 6. So 4 pi over 6 equals 2 pi over n. So I will cross multiply and divide, and that will tell me that n is what?
3 pi.
No, not 3 pi. Just 3. The pi's cancel. So, one more time, we're going backwards of what we normally do. Normally you have the equation, and I say find the period, and you say, okay, the period is 2 pi divided by coefficient. Well, this time, we know the period from the picture, but we don't know the coefficient, so we have to figure it out. All right, what about these other things? They're all zeros. If we're looking at the purple curve, there is no shift involved. It's starting right where it's supposed to start, and obviously it hasn't been lifted up or down. Now, the good news is, when I go to do this equation, this number will stay the same, this number will stay the same, and this number will stay the same. The only thing that's going to change is the chunk I'm looking at. If I am looking at this as a sine curve, I'm going to start here, or here, or here, or here. I got to start on the axis, right?
So wouldn't it be plus?
So if you want to start here, that's absolutely fine. But there are other places you can start. But if you start here, you have a positive sine curve and a phase shift of negative pi over 6. So this is going to be x plus pi over 6. That will back you up pi over 6 units and start you in the right place. Brooke is back there reclining, looking at her watch. Just a few more minutes, Brooke. Let's see if we can get this calculator part done. Here we go.
We have a break. We didn't even get a
We
birthday.
don't need a break. This is fine. No.
Where is our birthday on this?
No. I want to finish this sheet. Here we go.
Can we get a birthday?
You guys are on permit break.
Wait, if we're done with it early?
Yes, if we get done with it, I done. When I finish this, we're done. There's only 5
Wait,
minutes.
can we get a birthday bonus on the quiz?
I'm already turned it in.
So,
Now, you get a point bonus because everybody's here and took it.
So I got 1 point.
All right. Number 11. What does the problem say? Find the angle whose tangent is 5, 6
In radian.
in radians. So I'm going to go to mode, set my calculator in radians, and I'm going to type second tangent, second tangent, 5, 6. And the answer to number 11 is 0.695. If you did not get 0.695, you probably didn't change your calculator into radians. The only way I knew that I was to answer in radians is the problem told me that. It could just as easily have said degrees, and then I would have typed the same buttons but gotten a different answer. Does everybody understand that? Next, find the sine of 12 pi over 17. So I simply type sine 12 pi divided by 17. You are right, 0.798. 0.798 is the answer. Number 13 is an equation to solve. So the first thing I want you to do is just solve the equation like always. So move things around. It says what? Sine x is going to equal what? If I move the 5 over and divide by 3, sine x equals 2/3. Now, what does the whole 0 to 360 thing mean? The whole 0, I gotta finish this worksheet or they're gonna kill me. God bless you. The whole 0 to 360 thing means I am looking all the way around the circle, right? All the way around the circle. So here's my circle. where am I going to find a sine value that's positive 2/3?
The second.
I'll find it in quadrant 2. Where else will I find it?
The first.
In the first. There are 2 answers to these equation problems, kids, because you're going all the way around the circle. If sine is 2/3, that picture could look like that or like this.
So there you trans.
It's in 1 and 2 because that's where the sine y is positive. No, I'm not done yet. My job is to find this angle and this angle. Those are the answers to the question. I need a calculator to do this. What am I going to type on my calculator? Yes, we can put it in degrees. That might be easier for us. Let's change our calculator into degrees. And I need to know x is an angle. And how do I find an angle on my calculator? Second sine. So second sine 2/3.
I get it now.
Did you get 41.8?
So whenever you got the negative one.
So what are the 2 answers to the problem? This angle right here is one of them. What's he?
41.8.
41.8. And the other one is this one, which is 131.2. 131.
131.8.
131.8.
I got 131. All you gotta do is add 90.
Okay, what was this one?
41.8.
130.
Okay, this is gonna be 180 minus 41.8. It cannot end in an 8.
138.18.
Wait, it's 138. 138.
Yeah.
138.2.
Yeah.
138.2.
You just add 90?
No.
No,
Subtract from 180.
you gotta subtract it from 180. You guys, I can't teach you that. You have to open your eyes and think. This is 180 degrees. You're not going 41.8 of it. You're stopping 41.8. You're not adding anything to 90. You don't know how big that is. This angle is sitting on the 180 line. So you're backing up 41.8
You did 180
from
minus
180. A flying squirrel is in a tree 18 feet above the ground. So here is the tree, 18 feet above the ground. Here's the squirrel. His angle of depression to a nut on the ground, so he's looking down at a nut on the ground. His angle of depression is 27. Where are we putting the 27?
by the end.
We're putting it down here. If you want to put it technically where it belongs, it's right here. I always make it the angle of elevation so it's in the triangle. How far is the squirrel from the nut?
So you're gonna try to find where it ends the tree, right? Oh no, that's the wrong one.
Where's the squirrel? Where's the squirrel? Where's the nut? How far apart are the squirrel and the nut?
X.
We don't know, but it's that line, right? Squirrel to nut. What function? Sine. Sine 27 equals 18 over x. So we'll multiply by x to clear the fraction. Right? And then divide. So 18 divided by sine 27?
That is
39.65. I'm taking their word for it. 39 point something. All right, last one. Find the angle of elevation of a duck in a pond to a hawk in the top of a tree at pond's edge if the duck is 100 feet from the base of the 32-foot tree. All right, so we have, here's the pond, here's a duck in the pond. and there's a hawk in the top of the tree, and we want the angle of elevation of the duck to the hawk. If the duck is 100 feet from the base of the 32-foot tree. So where do I put the 100 and where do I put the 32? 100 on the bottom because the duck is 100 feet from the base of the tree. Where do I put the 32? It's how tall the tree is. Your job is to find this right here. You want the angle of elevation. So what function? Tangent. You'll say tangent x equals 32 over 100. What button am I going to need to use? Second tangent. To find an angle, you must use second tangent. So second tangent, 32 divided by 100. Did you get 17.74?
Yeah.
17.74 degrees. Now, we just completed something called what? What is this paper called? Practice test.